Hello class, welcome to lesson 2.7, which is all about percent of change. By the end of this lesson you should be able to find percent of change and you should be able to solve problems involving percent of change. Let's start with some new vocab. We have percent of change is the ratio of the change in an amount to the original expressed as a percent. Okay? So percent of change is the ratio, we talked about those yesterday, the ratio of change in the ratio of change in an amount to the original amount expressed as a percent. Okay, so percent of increase, if the new number is greater than the original number. Okay, so obviously if something used to cost $10 and now it costs $20, there was an increase there. Percent of decrease, if the new number is lower than the original number. Okay, so let's say you bought something for $75 and then a couple months later you look at that same item and you see now it's only $60. Okay, that is a decrease. So let's talk about determining whether each percent of change is a percent increase or a percent decrease, then find the percent of change. Okay? So if we look at part A, our original price was 66 and our new price is 30. Okay, so is this an increase or decrease? This is going to be a decrease. This is what we like to see happen when we're purchasing stuff. Alright, so it's a decrease, and then we want to find the percent of change. So the way that you do that is you put the amount of change and then you divide it by the original price. Okay? The amount of change divided by the original price, and then you set it equal to r over 100. We are going to use proportions to help us solve these, okay? So I'm just going to quickly make these a little bit smaller so they're still on the page for you to reference, but gives myself some more room to write. Okay, so our amount of change, to go from 66 to 30, how much change is there? So you can do 66 minus 30 all over, what's our original price? 66 equals r over 100. You might be wondering why I have 66 minus 30. I did that because that's going to tell me how far apart the two prices are. Okay? So 66 minus 30, that's really just a 36 over 66 equals r over 100. And if I cross multiply, I'm going to have 3,600 equals 66r. And if I divide both sides by 66 in order to get r by itself, I'm going to end up with r being approximately 55, okay? So that means it's approximately a 55% decrease. And that's how I would write my answer, okay? I just wrote this here earlier as a reference to remember. It doesn't work out perfectly to 55, but I just kind of estimated there a little bit. And let's do the same thing with part B. If we look at part B, our original price is 9.8. Our new price is 12.1. And we want to determine, is it increase or decrease? So started at 9.8. Now it's at 12.1, so that's an increase. The number got bigger. And now we want to figure out what the percent of change is. So from 9.8 to 12.1, instead of writing it the same way that I did up here, I'm just going to write how far apart those numbers are. So if I do 12.1 minus 9.8, I know that they are 2.3 away from each other. And then I put it over my original price of 9.8, and I set that equal to my ratio of r over 100. Now if I cross multiply, I'm left with 230 equals 9.8r. tee it up, and to get r by itself, again, I have to divide. And so r is approximately equal to, see, 230 divided by 9.8 is going to give me approximately 23.5. So I'm going to say approximately 23.5% increase. Can anyone think of a time that increase is good for us? I know we don't like to have a decrease when we're buying stuff, but we do like to have an increase when we're selling stuff, right? We like to make money on things. So increase is great when you're selling. Decrease is great when you're buying. All right, go ahead and take a look at this first, go ahead and take a look at this first example on your own, see how you do. Hopefully you determined this was a decrease of 10%. If that's not what you got, be sure to ask for some help. Example 2. The number of cruise ships in North America increased 18% from 2000 to 2005. If there were 192 ships in 2005, about how many were there in 2000? Okay? So, it's a lot of words. Talking about cruise ships, and we know that they increased by 18% from 2000 to 2005. And we also know that there were 192 ships in 2005. So we want to figure out how many were there in 2000. Okay? When they already give you the increase, the way that you set that up, where we were writing R in the last example, that's where you write your percent. That stands for the rate. So we know we are going to set it up as 18 over 100 on that side because we know how much the increase is by. And now we want to know how many cruise ships were there in 2000. We know there were 192 in 2005. So we can use that to help figure out the amount of change, right? So 192 minus a number, because we don't know how many were in 2000, and then over our original. So is 2000 or is 2005 going to be our original? Which amount of cruise ships? It's going to be 2000, right? Because that comes first. So our original number is going to be how many cruise ships we had in 2000. So we represent that with just C, because we don't know how many that is. And now we have our proportion set up. And so if we do our cross multiplication, we have 19,200 minus 100C. You might be wondering how I got that. Well, I took my 100 and I distributed it to both items in the parentheses, and then equals 18C. If I keep going from there, I want to get my variable on one side. So I have a minus 100C on the left side, so I'm going to add that in order to get positive variable. So I have 19,200 equals 118C. Now if I tee it up again to get C by itself, I have to do what operation? I'm going to have to divide because I'm currently multiplying. And if I divide, I'm left with C equals, and then 19,200 divided by 118. That gives me 162.7. Okay, so 162.7 cruise ships, or how many there were in 2000. Except for one thing. I don't know about you guys, but I would not feel comfortable going on a cruise ship that is only 0.7% of the 0.7 there. So 70% of a cruise ship? No, I don't want that. That sounds like it would sink. So when you're dealing with objects such as cruise ships, we're going to have to round, okay? So we're going to say instead of 162.7, because that doesn't make sense, we wouldn't want to go on a ship like that, we're going to say about 163 cruise ships. Okay? That's about how many cruise ships there were in 2000. Alright, why don't you guys go ahead and take a look at this next example on your own and see if you can figure out what the price of jeans at the second store is. Hopefully you determined the jeans at the second store was $32.72. If not, be sure to ask for help tomorrow in class. Email me, ask a friend. So many options to get help. Make sure you take advantage of it if you need it. Alright, example 3. A meal for 2 at a restaurant costs $32.75. If the sales tax is 5%, what is the total of the meal? Okay, so for all of you who ask me on a regular basis, when am I ever going to use this in real life? How often do you go out to eat? And how much do you enjoy going out to eat? If you're like me, you enjoy it a lot. And so, sales tax, it's pretty much everywhere. So you should get used to being able to calculate some of that, alright? So a meal for 2 at a restaurant is $32.75, and sales tax is 5%. What is the total price of the meal? Alright, so we know that 5% of our total bill is going to be taxed. Okay, so we know that that is going to be added on to our meal cost. So the way that you can do that, I'm going to show you 2 different ways. You can do 32.75 times, and then remember percentages, you write as a decimal when you're working with them. So 5% is in the hundredths place, so 0.05. And then that's only going to represent the sales tax. Okay? And then we have the actual cost of the meal. And we want to know what our total is. Okay? So if we do 32.75 times 0.05, we end up with $1.64 plus our 32.75, and that tells us that our total cost for our meal is $34.39. Okay, that's after tax. But what if I'm feeling lazy and I don't feel like calculating this out and then adding it to the original cost? There's a shortcut, and I'm going to show you. The way that you do the shortcut, you take the original cost of the meal, so $32.75, and if I were to multiply $32.75 times 1, that would just give me $32.75, correct? Okay? But if I multiply it by 1.05, that is now multiplying it by the original cost and the sales tax, okay? So what you can do is you take the original cost of whatever the item is, you multiply it by 1 point, and then whatever your percent is gets tagged on, and then that automatically gives you the final answer, 34.39. So you can see that's much shorter, so if you can remember that shortcut, I highly recommend it. If not, the first way works just fine. Okay, go ahead and try this one on your own. Hopefully you ended up with $74.71. If not, be sure to ask me for help in class, or ask a friend, or watch the last example again, or read from your book. There's examples in there. Again, so many options. Man, what are you going to do with all these? Example 4, all right? This is our last example for the day. We have a picture frame originally priced at $14.89 is on sale for 40% off. All right, we like to hear that. We like discounts. We want to know, what is our new discounted price, okay? Since we love saving money, I find discount examples more fun than sales tax because I don't like seeing myself pay more money. So discount, pretty great, right? let's figure out how do we solve this problem. Let's think about it. Our original cost is $14.89, and we know we are going to subtract 40% of that price, okay? All right, we're taking it away. We don't have to pay that. So, again, you can do $14.89 times, and then our discount is 40%, so that's represented by 0.4, and that's going to give us our new price. Okay, so let's do that. $14.89 minus, and then if we multiply $14.89 times 0.4, we know we get to take off $5.96, bringing our new total to being only $8.93. I don't know about you, but I like that. But again, just like with the sales tax, there's a shortcut on discounts, okay? So our original price is $14.89, right? Okay? And if we were paying $14.89, we'd be paying 100% of the price, correct? Okay? So if we do 100% represented as a decimal, that's the same as just 1.00, or just 1 if you don't want the decimals. And we know we get to take 40% off of that price. So if we do 100% minus 40%, this now becomes 0.6. You're only paying 60% of the original price, right? So if, oops, that's a 9. If you do the original price times how much you are actually paying, you're done. So if I look at something and I see I get a 40% discount, that means I'm only paying 60% of the original price, and I can just jump to this step, and I can say $14.89 times 0.6, okay, $8.93. I'm done. I can also think if this would have been a 75% off, which is amazing, I know I get 75% of the original price off. That means I'm only paying 25%. So that means $14.89 times I'm only paying 25%, and then I would multiply that out, okay? So that one can be a little bit more confusing to figure out than the sales tax one. So if you understand one and not the other, that's okay. Or maybe you just prefer the first way that I showed you on both of those. Again, it's fine. They all get you to the same answer. It's just a personal preference. All right, this is the last example for you to look at on your own. Good luck. Hopefully, you discovered that the discounted price is now $16.99. Again, if you have questions on anything, be sure to ask either myself, a friend, rewatch the video, read your book. Again, so many options. Just be sure to reach out to someone if you need help. Have a great night, and I'll see you tomorrow.